Okay, so yesterday was test one. You should have that completed and submitted now. If there are any issues with that, send me an email. Those of you that have been submitted are graded in the grade book so you can see how you're doing. Make sure that you are watching your percent in Blackboard. Remember, 80% is a C, 70% is a D minus for a passing grade. But make sure you're watching that percent and looking at the grade scale in the syllabus so you know where you're at. If you have any concerns about your grade, let me know. Just like all of your quizzes, you can do corrections in the test. Just make sure when you redo the problems, you show your work. You'll have to submit those through email because Blackboard won't allow you to resubmit once something is graded. So you will have to email that to me. And again, just make sure that when you send that email in the subject line, give me your program. So that's dairy herd, auto tech, whatever. Or even just auto is all you really need to put in there. That'll let me know what section and course you're in. Just like any of the quizzes, those corrections, you can get back up to half your points. So that puts everybody in a pretty good spot. We did a couple of perfect tests, but other than those, everybody should be looking at corrections. Even if you only get a couple of points back, those add up a lot over time throughout the semester. So make sure you're working on those. Also out there, couldn't remember if I mentioned it to this group or not. There's an extra credit assignment. It's a little bit of a difficult volume problem, and I will give you until noon tomorrow. That's also on Blackboard in the course information for week 3. So if you'd like to complete that, that is up to 10 points extra credit. So some ways to help out your grades. Make sure you do the corrections. If you want to take a pop at the extra credit, go for it. As a group, we're doing pretty well right now. So just a quick summary, assignments that you should have submitted at this point that should be submitted and in the grade book. You should have quiz 1, quiz 2, and test 1. So those should be submitted for you. If they're not in, contact me right away. We'll get you caught up with those. Okay, so if anybody have any questions on that part and stuff we've completed in Unit 1? Okay, so then today we are moving on to Unit 2. Unit 2 deals with some of our other common forms of numbers. The big theme of Unit 2, fractions and decimals. So we are going to start out today working with fractions. Now, we mentioned way back on day 1, 3 weeks ago, that a fraction like this, 3/4, that top number, of course, is the numerator, which we said is just a count. That's saying we have 3 of something. And the bottom number is a denominator. Which we said was a name. So it's not 2 numbers, it's 1 number with 2 parts. Just like having 3 inches, 3 pounds, 3 cows. Here we have 3/4. So one of the first things we need to do is define what does it mean to have a name of a fourth. Well, probably the easiest way to illustrate that is to go back to the old elementary school illustration of a pie or a pizza. Pretend that looks like a circle. And it's cut into 4 equal pieces. So we can look at it one of 2 ways. Pretend those look equal too, by the way. We can look at it one of 2 ways. Either every whole object gets cut into 4 equal pieces, or it takes 4 of these pieces to make a whole object. And then, of course, the 3 part of it, then the count means that we have 3 of those pieces. So now one of the first things we need to be able to do is we need to be able to rename that fraction. One of the simplest ways we can rename that fraction is to take those current pieces and cut them into more smaller equal pieces. So I'm going to take each slice here and I'm going to cut it into 3 smaller equal slices. Again, pretend those are equal. Now if I look at it, instead of having 4 slices to make the whole object or whole pizza, I now have 12 slices. I had 4, each of them got cut into 3 equal pieces. So 4 times 3 gives me 12. And instead of having 3 out of those 4 slices, now I have, you can see in yellow there, numbered up to 9 slices that I have. We had 3, cut each into 3 equal pieces, so 3 times 3 equals 9. Well, do I have any more or less than I did before? No, I have exactly the same amount. The size of the yellow section there did not change. 9/12 is exactly the same amount as 3/4. It just looks different. Well, how was I able to do that? How was I able to make it look different without changing its amount? Well, it has to do with what we did right here. That was 3/3. We multiplied by 3/3. Well, the bottom number there is saying it takes 3 pieces to make a whole object. Top number is saying we have 3 pieces. In other words, that's equal to 1. When you multiply or divide by something that's equal to 1, it does not change the value, but it can change its appearance. That is referred to as a unity fraction. It is a very powerful tool in math. One of the things we use it for is to change the name of fractions or to reduce fractions that we'll see in a few minutes. But it's also used in our measurement conversions and a lot of other things, dosage calculations and medical math and stuff like that, where we need to change the appearance or change the form of a number without changing its value. Now in this example, I just picked the 3 out of the air and used it to rename the fraction. In many cases, we will have a fraction. Let's say we have 2/5. And we will know what we need to rename it to. Let's say we need to rename this to 20ths. So we have to figure out what we need to multiply by to change that name. So what do I have to multiply 5 by to turn it into a 20? Well, it'd be 5 times 4 to make 20. That means I have to multiply the numerator, the top of that fraction, by 4 as well, so that I'm multiplying by 4/4, or 1. Well, 2 times 4 is 8. So 8/20 is exactly the same value as 2/5. Or we might have 1/2, and we need to change it into 16ths. Well, again, we look at it. 2 times 8 makes 16. So I have to multiply 1 times 8 as well. 1 times 8 is 8. Again, 8/16 is exactly the same value as 1/2. So I can change the name by multiplying numerator and denominator by the same thing. But sometimes I need to go the other direction. I need to simplify or reduce. For this example here, we multiplied both the numerator and denominator by 4 to change 2/5 into 8/20. If I want to go the other direction, if I want to change that 8/20 back into 2/5, well, I can divide both the top and bottom by 4. Remember, there we're dividing by 4 over 4, which is still 1. And dividing by 1 does not change the value. 8 divided by 4 is 2. 5 divided by 4, or 20 divided by 4 is 5. And as we said, we've already established up here, 2/5 is the exact same value as 8/20. Well, it's not always quite that simple. We're not always given, this one we'd already multiplied by 4 to make it into the 8/20, so we knew we had to divide by 4. Not all of our fractions are going to be that simple to figure out what to divide by. Now, we'd mentioned on Tuesday, the last day of Unit 1, something called the greatest common factor. And that's something, when you started working with fractions, that's something your teacher stressed to you. Find the greatest common factor of the numerator and denominator. In other words, for this 48 over 60, find the largest number that divides both 48 and 60 so you can reduce it. Well, that's not necessary. We can look at 48 and 60, and using our divisibility rules, we know they're both even, so we know they're both divisible by 2. 48 divided by 2 is 24. 60 divided by 2 is 30. 24 over 30 is exactly equivalent to 48 over 60. We've just reduced it some. However, we look at that, both 24 and 30 are still even numbers, which means we can still divide both of them by 2. 24 divided by 2 is 12, and 30 divided by 2 is 15. Again, 12/15 is exactly equivalent to 24/30 and is equivalent to 48/60. Now, looking at it, the 15 is no longer even, so we can't divide by 2 anymore. But 1 plus 2 is 3, that's divisible by 3. 1 plus 5 is 6, that's divisible by 3. Both 12 and 15 are divisible by 3, so we can divide out a 3. 12 divided by 3 is 4. 15 divided by 3 is 5. And that is as far as we can go. 5 is a prime number, so we can't reduce that any further. 4/5 is equivalent to 48/60. Notice we reduced it 3 times with 3 different numbers. That's fine. We don't have to find that largest number, that greatest common factor. We just find any common factor and start reducing and go from there. Now, you might have seen or taken the time to figure out using the factoring or whatever. There is a greatest common factor, obviously, and that's 12. If I had divided both 48 and 60 by 12 right away, 48 divided by 12 is 4, 60 divided by 12 is 5, I would have got the 4/5 in a single step. But unless that 12 sticks out at you, the effort it takes to figure out that 12 is the largest common factor, it really takes more time to do that than it would to just divide by 2 and then keep going, find any common factor, and then keep dividing down until you can't divide down anymore. We might have 35 over 75. We see both of those are divisible by 5. They both end in 5s. So divide them out. 35 divided by 5 is 7. 75 divided by 5 is 15. 7 is a prime number, so that's as far as we can go. So we can reduce our fractions by dividing the top and bottom by the same number, just like we can rename them by multiplying the numerator and denominator by the same number. Well, now we can run into something like this. Let's do 44 over 7. Now remember that 7 is telling us that it takes 7 pieces to make a whole object. And we have 44 pieces. We have more than enough pieces to make a whole object. In fact, we have enough pieces to make several whole objects. So the question is, how many whole objects can we make? Well, one way we could figure that out, I suppose, is we could do 44 divided by 7. Now, if you punch that in on your calculator, you're going to get something like 6.2857143. That actually, it's ugly, but it does tell us some information. It is saying we get 6 whole objects. Now, the rest after the decimal point doesn't really tell us much. All it says is that there's stuff left over after those 6 whole objects. So we know this is going to be 6 whole objects, but we still need to know how many pieces left over. Now, those pieces are still going to be 7s. It still takes 7 of those pieces to make one whole object. Rather than dividing it out on a calculator like this, it often works better to just do a long division. 7 goes into 44 6 times. That's our whole objects. 6 times 7 is 42. Subtract, there's 2 pieces left over. That is the pieces that are left over. So this is 6 and 2/7 is equivalent to 44/7. Now, the 6 and 2/7 is referred to as a mixed number, because it mixes whole numbers and fractional parts. The 44/7 is often referred to as an improper fraction, which is not really a great term because it implies that there's something wrong with it. The word improper implies there's something wrong with it. That's not true. There's absolutely nothing wrong with the 44/7. In fact, there are going to be times where we want it that way. Some textbooks get away from the notation of improper fraction. They just call it a top-heavy fraction. If you see the term top-heavy fraction, it means the exact same thing. So, if we have 23/4, we need to change that from an improper fraction to a mixed number. Well, we're going to do 23 divided by 4. 4 goes into 23, 5 times. 5 times 4 is 20. There's 3 left over. So again, the 5 is our whole objects. The 3 is the pieces left over, and of course the name is still fourths. Not always that simple. We can run into some weird denominators or some extremely large numerators. We might have 285/11. That's going to be 285 divided by 11. 11 does not go into 2, so we leave it blank above the 2. 11 goes into 28 twice. 2 times 11 is 22. We subtract, we've got 6. We bring down the 5. 11 goes into 65 5 times. 5 times 11 is 55. There's 10 left over. We're at the end of our number now. So this is telling us there's 25 whole objects and 10 pieces. So 10 of those 11ths left over. We mentioned that often we want to go the other way. We want to take that mixed number and go back to an improper fraction. If I have 3 2/5 and I want to turn that back into an improper fraction, what I have to do is take these 3 whole objects and break them into pieces. Well, how do I know how many pieces each of them is? My denominator tells me that each whole object is 5 pieces. So those 3 whole objects, I go 3 times 5 gives me 15 pieces. I take my whole number, tells me how many whole objects, times my denominator tells me how many pieces per object. Gives me the number of pieces in that whole number portion. Now I already had 2 pieces before. So I add my 15 pieces from the 3 whole objects. 2 plus 15 is 17. And of course my name stays fifths. So I might have 7 3/4. I'm going to do the same thing. My whole number times my denominator. 7 times 4 is 28. I add that to my numerator. 3 plus 28 is 31/4. So now we've looked at renaming all of our fractions and changing the form. Let's look at working with them. Remember, when we add or subtract, must have the same name. For fractions, that is that common denominator. With any form of number, we're going to combine the counts. No matter what operation we're doing, we're going to combine counts in some way. But when we add or subtract, we keep the same name. And remember, for fractions, that means keep the common denominator. Let's take a peek at an example here. Let's do 3/4 plus 1/6. When I go to add two fractions, we have to have the same name. We have to have the common denominator. So that's the first thing we need to figure out, is how do we find a common denominator? Well, some of you have done enough of these that you can probably just look at that and figure out what the common denominator is. But if you don't see that right away, how do we figure that out? Well, one option is just to multiply. In this example, if I just do 4 times 6, I get 24. That will be a common denominator. But remember, on Tuesday, we talked a little bit about least common multiples. There's also the least common denominator. Multiplying the two denominators will always work. It'll always give us a common denominator, but it might not be the smallest one. There might be smaller ones that are simpler, easier to use. One thing we could do is lists. We do our multiples like we did on Tuesday. 4s would be 4, 8, 12, 16, 20, and on up. 6 would be 6, 12. Well, there it is right there. There's our first common multiple, or common denominator is 12. That's smaller than 24, so it'll be a little bit simpler to use. We also have the factoring techniques that we looked at on Tuesday, but we're not going to go over that again here just because of time. But what we found is we have a common denominator of 12. So let's take a look at this addition. Now, I tend to add vertically just because that's the way my mind thinks for addition. So I have my 3/4 plus 1/6, and I'm going to change them to that common denominator of 12. Well, it took 4 times 3 to make 12, so 3 times 3 would be 9. 9/12 is equivalent to 3/4. 6 times 2 makes 12, so 1 times 2 is 2. 2/12 is equivalent to 1/6. Now we add, now that we have the same name, we combine counts. 9 plus 2 is 11, and we keep the same name at 12. 11/12. Now I had said we could have just multiplied to get a common denominator, that 3/24 there. Or the 24th, I should say. We could use 24 as our common denominator. As we said, it might be just a little extra work. 4 times 6 makes 24, so 3 times 6 is 18. 18/24 is equivalent to 3/4. 6 times 4 makes 24, so 1 times 4 is 4. 4/24 is equivalent to 1/6. And we add 18/24 plus 4. We combine counts. 18 plus 4 is 22. Keep the same name of 24s. Only we see at this point that both of those can be divided by 2. 22 divided by 2 is 11. 24 divided by 2 is 12. We get the same answer. We just had to go through those extra steps at the end to reduce it. So if you're stumped on finding a least common denominator, you can't always just multiply the two together. Get a common denominator, and you may have to do some reducing at the end. Now, I'm not going to spend any more time with simple fractions. We're going to bump up to mixed numbers. So we might have something like 4 2/5 plus 3 1/8. Oh, let's go 3/8. Keep it interesting. Now with mixed numbers, we still need a common denominator. Now some textbooks just have you rewrite the fraction, rename it. I bring the whole number over with it just so I keep things together. Between 5 and 8, my common denominator is 40. 5 times 8 makes 40, so 2 times 8 is 16/40. 8 times 5 makes 40, so 3 times 5 is 15/40. Now you might notice the way I have those set up, I have the fraction sitting at the end lined up, almost like it's just the last digit in the number. When in fact that's exactly what it is. The fraction is nothing more than the last digit at the end of the number. You know, this was the ones place, there'd be the tens place here. This is the fractions place. Now I had to rename that fraction portion to give it the same name, common denominator, but it's still the last digit at the end of the number. So we always start on the right and work our way back to the left when we add. So we start with the fraction. 16 plus 15 is 31. We keep the same name of 40th. 4 plus 3 is 7. Now it isn't always that easy. We can run into something like this. 6 3/4 plus 2 5/8. We need a common denominator, which in this case is just 8. Oftentimes, one of the denominators is our common denominator. 4 times 2 makes 8. 3 times 2 makes 6. So 6/8 is equivalent to 3/4. Well, 5/8 is just going to stay 5/8. So again, we treat that fraction like the last digit at the end of the number, so we add it first. 6/8 plus 5/8 is 11/8. Now that is an improper fraction. 11 is bigger than 8. So we can break that down into a mixed number. 8 goes into 11 once with 3 left over. Just like with whole numbers, we're going to keep part of this. We're going to keep the fraction portion in the fraction digit, and we'll carry the 1. 1 and 6 make 7, plus 2 is 9. That is 9 3/8. So the key to adding fractions, and it's going to be the key to subtracting fractions as well, is treating that fraction as though it's just the last digit of the number so that we can carry and borrow and all that as well. So we're going to jump up to subtracting. We're going to stay with mixed numbers rather than simple fractions. We might have 8 2/3 minus 5 1/2. Our common denominator here between 3 and 2 is going to be 6. 3 times 2 makes 6, so 2 times 2 is 4/6. 2 times 3 makes 6, so 1 times 3 is 3/6. And again, that fraction is just the last digit at the end of the number. And we start on the right, work our way back to the left. So we're going to do the fractions first. 4/6 minus 3/6. Combine the counts. 4 minus 3 is 1. Keep the same name as 6. 8 minus 5 is 3. Now again, it's not always that easy. We might have 9 1/8 minus 6 5/6. Our common denominator here between 6 and 8 is going to be 24. 8 times 3 makes 24, so 1 times 3 is 3. 6 times 4 makes 24, so 5 times 4 is 20. We go to subtract, we start on the right, work our way back to the left, but we hit a problem. We can't do 3 24ths minus 20 24ths. So just like with whole numbers, we're going to borrow. We'll borrow from the 9, that becomes an 8. Now we have to be careful because what we borrowed was one whole object. But remember, the fraction represents pieces. Well, the denominator of the fraction tells us how many pieces are in that one whole object. There's 24 of them. So we take our 3 pieces that we have, and we're going to add 24 to it. That's 27 24ths. And now we're going to subtract. 27 minus 20 is 7. and we keep the same name of 24ths. 8 minus 6 is 2. Let's do one more example of borrowing. Let's do 423 and 1/4 minus 159 and 3/5. So again, we need a common denominator. Between fourths and fifths, it's going to be 20ths. 4 times 5 makes 20, so 1 times 5 is 5. 5 times 4 makes 20, so 3 times 4 is 12. Once again, starting on the right, working our way back to the left, 5 20ths minus 12 20ths can't be done. So we're going to borrow from the 3. This becomes a 2. Now again, the denominator here tells us how many pieces are in that one object we borrowed. This is a 20, so we're going to add 20 to our numerator. 5 plus 20 is 25 20ths. Now we have 25 minus 12 is 13. We keep the same name of 20ths. And we move on to the next digits. Well, 2 minus 9 can't be done, so we're going to borrow. That's 1 and 12. 12 minus 9 is 3. 1 minus 5 can't be done. We borrow again. This is 3 and 11. 11 minus 5 is 6, and 3 minus 1 is 2. Time to move on to multiplication. We might look at something like this. 2/5 times 3/4. When we multiply or divide, we do not need the same name. We combine counts, as always, but then we also combine names. So what does that mean for fractions? Well, it means we do not need a common denominator. We do not need the same name. We're going to combine the counts. 2 times 3 is 6. And then also combine the names. 5 times 4 is 20. Now 6 and 20 can both be divided by 2. 6 divided by 2 is 3, and 20 divided by 2 is 10. So 3/10. Now some of you might have been looking at this original problem asking, why didn't he cross-cancel? Others right now might be asking, what's cross-canceling? Well, what it is we notice that the numerator of our answer is going to be just the two numerators multiplied, 2 times 3. And the denominator is going to be just the two denominators multiplied, 5 times 4. Well, if I look at that, I realize that the 2 and the 4 can both be divided by 2. So I can do that before I multiply. 2 divided by 2 would be 1. 4 divided by 2 would be 2. Now when we multiply, 1 times 3 is 3. 5 times 2 is 10. We reduced before we multiplied. Now in a problem like this one, it's about the same amount of work to reduce first, to cross-cancel, or to reduce when you're done. But we can run into problems like this. 24 25ths times 35 36. We could multiply this out. 24 times 35 is 840. And 25 times 36 is 900. Well, we can use our divisibility rules. They both end in 0, so you can divide by 10. That's 84 over 90. They're both still even, so we can divide by 2. 42 over 45. They both still can divide by 3. 42 divided by 3 is 14. 45 divided by 3 is 50. We get down to 14/15. I mean, that's doable, but you work with some pretty large numbers. To me, it's a lot simpler to look at this original problem and see, hey, 24 and 36 both divide by 12. 24 divided by 12 is 2. 36 divided by 12 is 3. 25 and 35 both divide by 5. 25 divided by 5 is 5. 35 divided by 5 is 7. Now I do 2 times 7 is 14, and 5 times 3 is 15. That's a lot simpler to me. Let's jump up again to multiplication with mixed numbers. Let's go 2 1/4 times 5 2/3. Now, multiplying mixed numbers is an extremely difficult process. If you went to a university and found 10 math majors, I'd be willing to bet that none of them could show you how to multiply mixed numbers correctly. So how are we going to do it? Well, we're going to cheat. We're going to change them into improper fractions so that we don't have to work with the mixed numbers. So 2 1/4, 2 times 4 is 8, plus 1 is 9, so that's 9/8. Times 5 2/3, well, 5 times 3 is 15, plus 2 is 17 thirds. Now I can cross cancel just like any other fraction here. 9 and 3 both divide by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. Now I multiply. 3 times 17 is 51. 8 times 1 is 8. And I do have to reduce that down to a mixed number. 8 goes into 51 6 times. 6 times 8 is 48. There's 3 left over. So that's 6 whole objects with 3 pieces or 3/8 left over. If we have time at the end, I'll come back and I'll show you how you actually would multiply those as mixed numbers. Not a terribly pleasant process, but I'm going to leave a little room here just in case we have time to come back to it. We'll do one more example here. Let's do 2 1/2 times 4 let's do 3/8. So again, we have to change them into improper fractions. 2 times 2 is 4, plus 1 is 5/2. 4 times 8 is 32, plus 3 is 35/8. Now it looks like we should be able to cross cancel here, but we can't. Nothing's diagonal. So we do 5 times 35 is 175. 2 times 8 is 16. And we do have to reduce this. Often this is the most difficult part of multiplying mixed numbers, is reducing that improper fraction at the end back into a mixed number. Well, 16 does not go into 1, so I leave it blank above the 1. 16 goes into 17 once. 1 times 16 is 16, so I subtract, there's 1 left over. I bring down the 5. Now 16 does not go in the 5, but I have to fill the digit above the 5, so I have to put in a 0. So this is 10 whole objects with 15 16ths left. Division. We've said that division follows the same rules as multiplication. And when we multiplied straight across. So does that mean that when we divide, that I can divide straight across? Can I do 12 divided by 4 is 3? 25 divided by 5 is 5. Does that work? Well, is that the correct answer? It actually is. Does that work every time? Well, it sure does. Well, why don't we divide like that then? That's not what we were taught how to divide. Well, the reason we don't divide like that is because we run into problems like this. 3/4 divided by 2/3. Well, if we tried to divide that across, 3 divided by 2 is 1 1/2. And 4 divided by 3 is 1 1/3. They don't divide out evenly. So what we were taught to do was to multiply by the reciprocal. The division works on the number that comes after it. So the 3/4 stays the same. Just like when we're dealing with negatives, when we subtract, we add the opposite. When we're dealing with fractions, when we divide, we multiply by the reciprocal. The reciprocal of 2/3 is 3/2. We just flip it over. Now we multiply. 3 times 3 is 9. 4 times 2 is 8. 9/8 or 1 1/8. Now, believe it or not, that process of multiplying by the reciprocal came from this process here. Let me show you how briefly. You don't need to write this down because I won't ever force you to do it. but it's nice to know where things come from. The long process, or the actual process of dividing fractions, looks like this. 3/4 divided by 2/3. We see that it's not going to divide out evenly in the numerators and denominators. So I look at the number, the fraction I'm dividing by, 2/3. First of all, it's fully reduced. Second, I take my numerator 2 times the denominator of 3, gives me 6. I am going to use that 6 to rename my first fraction. So I'm going to take my 3/4, and we'll multiply by 6 over 6. 3 times 6 is 18. 4 times 6 is 24. 18/24 is exactly equivalent to 3/4. Now I'm going to go ahead and multiply by 2, or divide by 2/3. 18 divided by 2 is 9. 24 divided by 3 is 8. 9/8, or 1 1/8. Exactly what we got over here. Well, how did we jump from this to just multiplying by the reciprocal? It's not as big of a logical leap as you might think. At some point, somebody looked at this problem and realized, well, we have 3/4 times 6 over 6 divided by 2/3. And they realized that if we fudge our order of operations just a little bit, this is actually one of the allowable exceptions to the order of operations if you were to get into a little bit more complex number theory. If we did this division first, 6 divided by 2 is 3. 6 divided by 3 is 2. What we get there is always just this fraction flipped over like this. And then, of course, what's left is to do the 3/4 times that. Of course, that is multiplying by the reciprocal. So when we multiply by the reciprocal, when we divide fractions, all that is a shortcut for doing all of this mess. We just know that it's going to come down to multiplying by the reciprocal, so we skip all of this stuff over here. Well, let's jump up to dividing mixed numbers. Let's do 4 1/8 divided by 1 2/3. It makes sense that if we're going to turn it into multiplication, that we start out with the same step we did with multiplication. And that's turning them into improper fractions. 4 times 8 is 32, plus 1 is 33. That's 33/8. 1 times 3 is 3, plus 2 is 5. That's 5/3. Now, at this point, it is very tempting to cross-cancel, but we cannot, because right now it is division. We can only cross-cancel in multiplication. So let's change it to multiplication. The first fraction doesn't change. Remember, the division operates on the fraction coming after it. So it's going to be times 3 over 5. Now it is multiplication, and here we could cross-cancel if there was anything that canceled. Here there is not. 33 times 3 is 99. 8 times 5 is 40. 99 over 40. We're going to divide that back out. 99 divided by 40. 40 goes into 99 twice. 2 times 40 is 80. There's 19 left over. That is 2 and 19/40. I'm going to give you your homework here, and then for those of you that are interested, I'm going to go back and I'm going to do that multiplication of mixed numbers. There's actually going to be 3 pages here. The first is page 32 through 33, 1 through 49, the odds. Second is page 41 through 45, 1 through 89, the odds. And finally, page 49 through 52, 1 through 87, the odds. Now, again, I realize there is a ton of problems there. I don't expect that you're going to sit down and do 105 problems tonight. That's not my purpose. Again, if the first few seem pretty easy, skip ahead, do some of the more difficult ones. If there are word problems, story problems, make sure you do those. But fractions are one of those things that some people have them, so they don't need to do so much. Other people do need a lot of practice to get good at it. So I'm putting a lot of problems out there for that purpose. So you can practice if you want to. We've got a couple minutes. We're going to go back here quick and take a peek at our multiplication with mixed numbers. So we had 2 1/4 times 5 2/3. When we multiply, like if I have 42 times 23, this 3 has to multiply the 2, but it also has to multiply the 4. The same is true with our mixed numbers. The 2/3 has to multiply the 1/4. All 2/3 times 1/4, that's 2/12 or 1/6. But it also has to multiply the 2. So 2/3 times 2. How do we multiply a fraction times a whole number? Well, we make the whole number into a fraction by putting it over 1. So 2 times 2 is 4, 3 times 1 is 3, 4/3 or 1 1/3. The 5 has to multiply the 1/4, so we do the same thing. That's 5 over 1 times 1/4. 5 over 4, or 1 1/4. And then, of course, we have the 5 times 2. So now we need to combine those. To combine those, we need a common denominator. For 6, 3, and 4, it's going to be 12. So 1/6 is 2/12. 1 1/3 becomes 1 4/12. 1 1/4 becomes 1 3/12. And, of course, there's just the 10. 2 and 4 is 6, plus 3 is 9/12, which reduces to 3/4. 1 and 1 is 2, and 1 is 1. 12 and 3/4, which is exactly what we got up here. Oops, where was it? I did something wrong when I multiplied there. I did something very wrong when I multiplied there. What did I do wrong? I changed this from 4ths to 8ths somehow. That's why that went wrong. Good thing I went back and redid that. That should be 4, so this should be 51 over 4. That'd be 4, so this would be 1, 2, 3 left over. So 12 and 3/8. 3/4, sorry. So good thing I went back and redid that one. So I had totally messed that up when I did it with the improper fractions. Somehow I changed 4ths into 8ths. It should have been 9 over 4. Sorry about that. Okay, back to the homework so I don't confuse you. There's our homework. I'll let you guys have the last. We've only got a minute left, so we'll let you guys check out of here for the day. Remember, do corrections on the test. Those are graded and in Blackboard for you. Also, the extra credit is out there to submit by noon tomorrow if you get a chance, up to 10 points. And this is our kickoff to Unit 2. So you guys have a great weekend. We will see you on Tuesday.